Hello everyone, my name is Tong Duan. My supervisor is Professor Venkata. I will introduce the proposed works in this paper. The title is Heterogeneous Real-Time Co-Emulation for Communication-Enabled Global Control of AC-DC Grid Integrated with Renewable Energy. Okay, let's begin. In the latest trends, the information and communication technologies are widely deployed for both AC and DC equipment, as shown in this figure. With the communication function increasingly involved in power equipment, the communication-enabled control for AC-DC grids is required to be started. However, the global control schemes for hybrid AC-DC grids have not been investigated. So the motivation of this work is to design and evaluate the communication-enabled control schemes on real-time co-emulator of power system and the communication network. As shown here, the heterogeneous co-emulation platform is composed of the FPGA and the JSON board. The FPGA board is used to real-time power system simulation, which has already been used in many researches and products. The JSON Edge computing board is used for communication network simulation, which is mainly based on the pre-simulated transmission parameters. The data exchange between the two domains is achieved via the PCIe interface with driver functions to read the power system emulation results from the FPGA storage to emulate the sampling operations of electronic devices attached with the power equipment. The hardware implementation is shown here. We can see that two JSON FPGA platforms are interfaced via the fast QSFP link and RG45 network link. The test power system contains the AC and DC system with two offshore wind farms. The communication-enabled global control schemes are proposed for the two cases: power overflow of wind farm generation and DC fault protection. With communication-enabled, the global power system status could be obtained in real time. The emulation results show that the proposed communication-enabled global control schemes can improve the system stability compared to the traditional control schemes based on local status. To conclude this work, a heterogeneous hardware real-time co-emulator is proposed and built on multiple JSON FPGA platforms. The hybrid AC-DC grid with wind farms is emulated on the FPGA JSON-based co-emulator, and the communication-enabled global control schemes are investigated for the two case studies: power overflow and DC fault. The proposed heterogeneous co-emulator can be applied in fast emulation of practical large-scale cyber-physical power systems. The investigated global control schemes can be applied to improve the system stability and controllability. That's all. Thank you for listening.